Some reactions form a gas when we make that ion exchange. Here's an example. If you mix potassium sulfide and sulfuric acid, you get potassium sulfate and hydrogen sulfide gas. It smells a lot like rotten eggs. It's really pretty nasty. Other reactions are going to form gases because one of the products decomposes. If we mix sodium hydrogen carbonate, which is baking soda, with an acid like hydrochloric acid, or it works with acetic acid as well, we get an exchange. The hydrogen exchanges with the sodium. We end up with sodium chloride, and what would we call that? It starts with an H, though. That makes it an acid. So if we cover up the H's, what's left? CO3 has a name, as an ion, carbonate. 8 and ic, this is carbonic acid. Carbonic acid isn't stable. Carbonic acid will decompose into water and carbon dioxide. Bubbles, tiny bubbles, right? Tiny bubbles. That's what makes soda fizzy, is the carbon dioxide. So when I mixed the acetic acid with our precipitate from our precipitation reaction, we saw bubbles forming. It was this sort of a reaction. It was the acid reacting with the carbonate. And the carbonic acid that gets formed decomposes into carbon dioxide. There are 4 different types of reactions that can form gases. Sulfides, if you swap partners with your ions and you end up with H2S, you just need to remember that's a gas at room temperature. And so we've got a gas evolution reaction. Carbonates and bicarbonates. You're going to end up with, if you end up with H2CO3, this is carbonic acid, you need to remember that that is not stable, and it's going to decompose and form CO2. It's actually not that hard to remember. H2CO3. If I remove a water, 2 hydrogens and an oxygen from this, what's left? CO2. So I got rid of these 2 hydrogens and 1 of the oxygens. What's left is CO2. Sulfites and bisulfites, or hydrogen sulfites, you get a product H2SO3. H2SO3 is also unstable. It will lose a water molecule, and then we just look at what's left. We get rid of the H's and 1 of the O's. We get SO2, another smelly gas. If you get ammonium hydroxide forming as a product, this is also unstable. NH4OH. Water comes out, and what's left? We get rid of this H, this O, and 1 of these hydrogens. What we've got left is NH3, which is a gas. A very smelly gas. It's ammonia. So we've learned how to exchange ions in a double displacement reaction, and then various things can happen. Sometimes it's a neutralization reaction because we had an acid and a base. Sometimes it's a precipitation reaction because one of the products that's formed is an insoluble ionic compound. Or we can have a gas forming. The gas evolution reactions, you can see that something's happening. You see bubbles forming. That tells you, hey, I've got a reaction going on. The precipitation reaction, you can see that something is happening. The acid-base reactions, you really can't see that anything is happening. Limestone is insoluble in water, and they're telling us what Limestone is mostly calcium carbonate. Insoluble in water, but dissolves when hydrochloric acid solution is added. Write the molecular and net ionic equations for this reaction. Well, calcium carbonate. What's the formula for calcium carbonate? CaCO3. And what state should we give that? Solid. Because it's limestone. It's solid and it's insoluble in water. They told us that. Hydrochloric acid. That's HCl. That's aqueous. A hydrochloric acid solution is added. Okay, it dissolves. So let's see what could possibly be happening here. Well, what can happen is we can have ions switching places. Calcium ion and carbonate ion. Now, these are not in solution, but it's still possible for them to separate. And here is hydrogen and chloride, hydrogen ion and chloride ion. And so we're just going to predict what sorts of products could happen. Well, we get calcium and, no, not carbonate, calcium and chloride. And we would get hydrogen and carbonate. I'm not writing a total ionic equation. I'm just predicting products. It's a good question. These are just my little scribblings, which these little scribblings are actually really, really helpful because they show you the charges and you just rearrange them and then you've got everything set up to predict the formulas. So this is going to be calcium chloride. Is that soluble? I put it in water in the test tube earlier and it dissolved. I think it is. But we could also look it up in the table. And then what's this going to make? It's going to make H2CO3. And then we have to say, oh, that's one of those guys. I'm going to get rid of this stuff because I need the space. So I guess we would put AQ there. But then we have to recognize that this guy forms water and CO2 gases. So if we're going to write a molecular equation, we've got calcium carbonate, solid, and HCl, aqueous. Always a good idea to just leave a little space in case you need to put a coefficient in there. And I've got calcium chloride, aqueous, and, oh, let's just do it like that. I didn't mean to do that, but it worked out okay. Instead of this, I'm going to write what it decomposes into, water and CO2. And this isn't balanced. I need to balance it. There's 2 chlorines here, so I need to put a 2 over here. There's 1 calcium and 1 calcium and 1 carbon and 1 carbon and 3 oxygens, and 1 plus 2 is 3 oxygens. Here I've got 2 hydrogens and 2 hydrogens. So there's my molecular equation. Let's just write a very abbreviated complete ionic equation so that we can get to the net ionic equation. The calcium carbonate would not be separated into ions because it's a solid. HCl would be separated because it's a strong acid. So that's 2 H pluses and 2 Cl minuses. This is a soluble ionic, this one is a soluble ionic compound, and so we would separate that into ions. 2 of those. They've got a liquid and a gas. Those are not going to get separated. These are the only ions. We have 2 chlorides on that side and 2 chlorides on that side. And so those are the spectators, but everybody else is part of even the net ionic equation. So then we could copy that all down, at least somewhat neatly. I've got plus 2 H plus aqueous, and that's going to form Ca 2 plus aqueous plus water and carbon dioxide. And that's the net ionic equation. Any questions?